Okay, so in this video, I'm going to be going over quadratic equations and specifically focusing on some of the concepts behind how we can graph them efficiently, quickly. We want to, not have to be plugging and chugging and doing all these tedious calculations when graphing quadratics. We instead just want to be very good about understanding the concepts and how they work, because that's the key to really doing math well and accurately, and that's what makes it fun and all that. So let's go into some of these things by first focusing on what I like to always remind my students: key points when it comes to graphing or plotting quadratic equations, which would be the intercepts, y and x intercepts, and the vertex. If you know where these points are, you can pretty much graph the parabola with pretty good accuracy without having to do like really any other tedious calculations. And so let's look at this first problem so that we can get some insight on how this works. By first focusing, so let's read this actually. Number one, recall that the standard form of the quadratic equation is f of x equals ax squared plus bx plus c. And we're going to analyze the graphs of each of these quadratics below, which is here. We want to see what we notice about the value of c in each equation and the corresponding graph. So first, let's make sure we understand that c in this first graph on the left is equal to 3. Remember, we're using this equation. And c here is equal to negative 3. And try to see if you can figure out what the relationship is between 3 in this graph and negative 3 in this graph. What was that? I think I heard you guys say. Well, yes, this is the y-intercepts. The y-intercept here is at 3, or 0, 3 as a point. And over here, it's at 0, negative 3. Wow. Now, that ain't no coincidence. There's some powerful math reasons behind why that is. And that's what we're going to go into next. Let's first formally write what's going on here. Value of c is 3 in the equation y equals x squared plus 4x plus 3, which is the same as the y-intercept. And the value of c is negative 3 in this equation, which is the same as this y-intercept. Usually when we say y-intercept, we just want to talk about that one number. We'll say, what's the y-intercept here? 3. What's the y-intercept here? Negative 3. But I like to do both. I like to remind my students the y-intercept is a point. That way they don't mix it up with, these x-intercepts, and they make sure to think. That being said, let's move on to the next page. And what we're going to do is just draw 3 sketches of, random parabolas going through the y-axis. So xy, xy, xy. And let's go like 1, 2, 3, 4, 5 or something. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This gives some guidance on where the coordinates would be. Let me adjust this. Okay, so let's draw a parabola going through this point here, 2. And let's make it look like that. And so the y-intercept is at 0, 2. Assuming we're going by ones. All right, so what's the big deal? Well, hold on. Let's do another one where we have the parabola going like this. Through 0, 1. It's going downward. Again, don't worry about being Picasso. Just draw, some sketch that shows where the parabola is going through on the y-axis. And let's make one maybe like doing something crazy, like going like that. And so the y-intercept here would be at 1, 2, negative 3. So 0, negative 3. All right, so here's the thing. Here's the beauty about this. No matter what we chose as the y-intercept for the parabola to go through, the x-coordinates was always equal to 0. Let's write that in capitals. 0. The x-coordinate will always be 0. which basically is, what the y-intercept is. So like, by definition, the y-intercept is where the x value is 0 because it goes to the x-axis. And if we were to try to find this y-intercept by just using the equation, we would have to evaluate the equation for x equals 0, meaning that we would plug 0 into the function for the quadratic equation. So we would have f of 0. Remember what the equation for a quadratic is. Make sure you memorize it. Let me write it up here again. F of x equals ax squared plus bx plus c. This is going to be essential to your survival in this chapter, so make sure you memorize and remember this equation. So if we were evaluating this equation for x equals 0, we would have a times 0 squared plus b times 0 plus c. Now when we do this, 0 squared is just 0, so this just goes away, it becomes nothing. And this is also going to go away. And so we're actually just left with c. Meaning that the y-intercept will always be at the point 0 comma c in terms of a quadratic equation. Wow. I mean, I think it's cool. But the point is that you want to understand these concepts because this is what's going to allow you to really become very good at graphing quadratics. Because again, we want to not have to be plugging and chugging and doing all these tedious calculations to graph them. And my camera is, let me adjust that. Okay. Anyways, so let's practice applying this concept by just drawing some sketches that include the y-intercept and vertex for these 4 equations. So starting with this first one here, we have f of x equals x squared minus 4x plus 3. So identifying what a is 1, b is -4, and c is 3. Now, the y-intercept will then be equal to 3, because that's the value of c. And so you're going to have a point at 0 comma 3. So one of the points on the parabola will be at 0 comma 3. Now, what about the vertex? Let's remember the equation for the vertex, which starts with the x coordinate being equal to -b over 2a. -b over 2a, -4, so that'll be 4 over 2 times 1, or 4 over 2, which will give us 2. We then evaluate this for 2. Y will be equal to f of 2, which will be 2 squared minus 4 times 2 plus 3, which will be 4 minus 8 plus 3, which will be -1. Meaning that the vertex will be at 2 comma -1. Okay, now we're getting somewhere. So let's draw a sketch of this. Let's make sure that goes through 0, 3, and 2, -1. That's all we have to make sure it goes through with our sketch. And then I want to screw this up, so let me put it over here. 2, -1, and 0, 3. Let's just say 2, -1 is about over here. And the y-intercept will be then 0, 3 over here. Again, it's just a sketch. Don't worry about drawing, something that's, going to be hung up in a museum, because we want to recognize that this parabola is essentially doing this. That's what it's going to look like. And the vertex is, at 2, 1, so this will be the line of symmetry. And from that, we can find points on the other side. If 0, 3 is on one side, then this point will be 2 away from 2, so 4 comma 3. And there we go. So this is the goal with these problems, because when you develop this type of conceptual understanding, you're going to find that your graphing power will, exceed what you ever thought capable, and you'll be you'll be a pro. You won't be stressing out about these quadratic calculations. Anyways, enough of me rambling. Let me do the next one. So let's again identify A as 1, B as 2, C as 3, or C as 6. And so the y-intercept. And feel free, or I recommend, pausing the video and trying it on your own, and then unpausing it to see how you did. But here I go. Y-intercept will be 6. So we got a point there at 0, 6 thus far. Now we got to find the vertex. X will be negative b over 2a, so negative 2 over 2 times 1, or negative 2 over 2, which will be 1. And then y will be, let me just go to the next line, will be 1 squared plus 2 plus 6. Is that right? 1, 3. Hold on. Oh, negative 1. Negative 1. So you got to focus and pay attention to detail. Negative 1. Whew. I don't know why this negative 1 doesn't look like negative 1, negative. Pencil. Negative 1. Plug negative 1 into here. Negative 1 squared plus 2 times negative 1 plus 6. 1 minus 2 plus 6 will be 5. And so we then got our vertex at negative 1, 5. And again, let's draw a sketch of this. It goes through 0, 6 and negative 1, 5. We'll just call this negative 1, 5. And 0, 6 will then be above it. And so then the parabola will be opening upward, something like that. And from there, we can know what the line of symmetry. This is the green dashed line. And on the left, what will this point be? Reflecting 0, 6 will be, y will be 6 again, and x will be negative 2. Okay, so don't worry. I got some more challenging ones coming up below. Why? Because they got decimals. Students freak out when they got decimals, which is interesting, but you got to face them. So I would recommend getting a calculator for this one. This is really where you would want one. Even I would admit that. But let's get going. Let me just try to zoom in on this a little better. Maybe zoom out. The lighting here is not good. Right, here we go. Okay, so here A is negative 1, B is 7, and C is negative 5. So the y-intercept will be at negative 5, which is the point 0, negative 5. Let's separate this. Now the vertex, let's start with x. X will be negative b over 2a, or negative 7 over 2 times negative 1, or negative 7 over negative 2, which will be 3.5 for x. And y will then be equal to negative 1 times 3.5 squared, with 7 times 3.5 minus 5. y will be equal to -1, 3.5 squared first. $12.25 plus 7 times 3.5, 21, 22.5 minus 5, 12.25 minus 5, 7.25. Cool, cool. Then we got our vertex. Oh, let me box this. Our vertex will be at 3.5 comma 7.25. So don't get scared away because we got a decimal. You gotta learn to accept them because they're gonna be part of your life if you continue to be in math for the long run. But you know, no worries for now. Let's draw this XY axis. And the vertex will be 3.5, 7.25. So let's call it something over here, maybe. And remember, again, it's just a sketch, just to make sure you're getting practice with the conceptual ideas behind this. And the y-intercept will be 0, -5. Below the x-axis, over here. And peek up like that. And there we go. Nice. On this side, let's see if you can get this. It's 3.5 to the left over here, 3.5 to the right over here. On this side, it'll be 7, -5. Axis of symmetry. Cool. All right, one more of these guys for now. All right. Y-intercept equals 4.5, because our C is 4.5, and then we will have the point 0, 4.5. And let me actually write out the A, B, and C. A is -2.7, B is 9.1, and C is 4.5. Really hate squeezing work, so we'll make it fit nicely. Okay, so now, man. Okay, so now let's find the vertex, starting with the x-coordinates. -b over 2a, so -9.1 over 2 times -2.7. So -9.1. I think I just burped. Sorry about that. Well, actually, I'm not sorry. You can't even smell it. Sorry again about that. 5.4. Yeah, sometimes I'll just say what's on my mind. 9.1 divided by 5.4. About 1.68518551885. Let's just round it to the one over there. So where did I put this? I know I'm going to use a pencil to make it smaller. 1.685.2. And from that, let's find what the y value would be. Plugging that into here. -2.7 times 1.68552 squared is 9.1 times 1.6852 and a plus 4.5. I mean, I hate doing this stuff like this. Plus 4.5 to that. And this will lead then, backtrack, or let me just put it over here. So we don't get confused, even though it probably is confusing by how I organize that. And I like to use my powerful calculator because I mastered the math already. negative 2.7 times 1.6852. This will be raised to the second power. I'm going to add 9.1 times 1.6852. Then add 4.5 to that guy. And bang, 12.16-ish. Rounding, of course, 12.16759. And so let's put this together all at once so that we can save space. So the vertex is at 1.6852, comma 12.16759. The y-intercept is at 0, comma 4.5, so it will always be above the y-axis or above the x-axis, be positive. And let's just say it's over here. The vertex here will be at 1.6852, comma, and if it is here, 12.16759. And the y-intercept will be at 0, comma 4.5, so over here. We'll just say we know it's below that. And so it's going to do something like this. Bang. There we go. And that's the main thing that you want to catch on with this part of the lesson, or with these types of problems, because again, you want to build that conceptual understanding of quadratics, and eventually these won't be an issue. These will be like, child's play. Feel free to take a break. I know that those probably some interesting problems, and then let's get back to it. And we're now gonna go into what the deal is with the x-intercepts. So turning the problem forward, it says return to problem 1, and this time factor each equation, or this time factor each equation and write the factor form below its graph. What do you know about the factored form of each quadratic equation and its graph? Okay, so let's see what's up. And already done. Here's the first two quadratic graphs that we looked at in this lesson, and the factored form are right here. So look closely. If you look at the factored form, we got a 3 and a 1, and a 3 and a negative 1. The x-intercepts here are -3 and -1. -3, 0, and then -1, 0. And here we have +3 and +1. -3, -1, +3, +1. Looking at this one, +3, -1. We got -3 over here, and +1 over here. +3, -1, +3, +1. So yeah, you get the picture. They're related to the x-intercepts where they're the opposite numbers. If it's positive here, that means the x-intercept is negative. If it's negative here, it means the x-intercept would be positive. And that essentially is what's going to happen in any quadratic that's factorable. So it's a big deal, guys. Let's write this answer out formally. And then I have it over here on this page. Let me write this. Let's write the factored form. Let's go jump to it here. The factored form of y equals x squared plus 4x plus 3 is y equals x plus 3, and y equals x plus 3 times y. Y equals x times 3 times x plus 1. And the x-intercepts are -3 and -1. So again, let me just highlight it. These are the opposites of 3 and 1, or +3 and 1. And for the other guy, y equals x squared plus 2x minus 3, we got the factored form y equals x plus 3 times x plus minus 1. And the x-intercepts are -3 and +1. which are the opposites of +3 and -1. This is a big deal. That's why I'm doing. That's why I'm making the time to, read this and try to make a big deal about it because it is. So sorry if I'm annoying, but that's why it's a video, so you can always skip it. But this is a big deal if you want to master this stuff and become, like godlike with your graphing skills. Anyways, let's get going on to what this means in terms of how we can approach each function. So let's now draw 3 sketches like we did with the y-intercepts of 3 random parabolas, but this time going through the x-axis. I'm going to see what's going on. So you got this. And again, you don't have to worry about being Picasso. Just do your best. Let's draw one going down like this. All right, looks good. And let's just call that, they both have to be positive, so we'll call that 1, 0 and 5, 0. Not a problem. Let's make one going upwards like this. And let's make, this will be negative, so let's just say that's -3, 0. That's +3, 0. Cool, cool. And let's just make one that just has 1 x-intercept. Let's just call that 4, 0. A little crooked, but all right. So what am I getting at? Whenever you have x-intercepts, the y values will be 0. Remember, these were just random. I just picked them. And you can pick your own, and the y value will always be 0. That's just how it works. That's basically the definition of x-intercepts. So similar to like what we learned about the y-intercept, this means that if we were given a quadratic equation and we want to find the x-intercepts, then we basically just have to evaluate the equation for y equals 0. And let's see what happens, or what we're looking at. That means we're not plugging 0 in for x. What we're going to have is 0 being equal to the equation. 0 being equal to ax squared plus bx plus c. Now, this is a little more complicated to solve than with the y, but the idea is to factor out the x values if possible, so it would look like a product of numbers or grouped terms, something like this. And I didn't want to squeeze that in there, but that's why I have a sticky note. Let me throw a sticky note on this side and make that equal to a times x minus x1 times x minus x2. x1 and x2 are the x-intercepts. To distinguish them from x are the 2 x-intercepts. Now, depending on your textbook or course or teacher, they may use a different notation, but it's really not a big deal, as you will see, because let's go ahead and do some example problems so we can really understand this stuff. So the idea then is based on this. If we can factor it, then the x-intercepts are easy to find. So we can easily identify the x-intercepts by solving the factors. So the x-intercepts are, what's with this pen, are easily identified by solving the factors, all right, speaking out, your job is done by solving the factors. So what does that mean? Well, I will show you in this next problem here. I can really see that ink. Okay, so let's use this technique of factoring to find the coordinates of the x-intercepts of each of the quadratic equations here. And then we're going to draw a simple sketch of what it could look like going through the x-axis. Okay, so if you remember how to factor, which you should, there are many ways to do it. But what I usually will set up with my students is this x diamond where we have a times c on top, b in the bottom, and a over something and a over something, and 2 numbers that we add up, or 2 numbers that multiply to the top and add to the bottom. We're doing it for real now for this first one. I'm gonna make a small one, another diamond below. A times C will be 1 times negative 15. We'll have negative 15 on top. A is 1, so we're gonna have 1 over something, 1 over something. And B is negative 2. So two numbers that multiply negative 15 and add to negative 2. That's right, negative 5 and 3. And so we're going to use these four numbers, 1, negative 5, 1, and 3, for our factored form. So we're going to have 1x minus 5 times 1x plus 3. And so here's the real power of this. The x-intercepts will be 5 and negative 3, or the points 5 comma 0 and negative 3 comma 0. What's up with this 3? There we go. So that's what you want to get out of this. I really don't like that negative 3. I'm going to use a whiteout and rewrite it. Negative 3 comma 0. So let's draw a sketch to really show what's going on here. At the x-axis, the y-axis, negative 3, 0 over here, and 5, 0 over here. Now let's think. Is this going to open up or down? Well, it's obviously going to open up because A is positive. A is 1. So it's going to open up. Also, we know the y-intercept is negative 15. So we know it's going to go through the point 0, negative 15. But wait, there's more. Don't use this as the vertex. Remember, the vertex is going to be in the middle of any two, or let's just, well, let me just teach or tell you this and teach this to you now, because it makes the most sense. If you split this in the middle, the point that's right in the middle of negative 3 and 5 is actually 1. It's actually the point 0, 1. Or no, 1, 0, I mean. And that's going to be where the line of symmetry is going to go. It's 1, it's at 1, 0 because 1 is 4 away from negative 3 and 5. So you can actually then get a better sense of what the graph will look like by, drawing the graph. This is very bad sketch, but it's okay. Because this is what will allow you to really start getting to understand how all these characteristics connect. I did that as, just for extra fun. Right now, let's focus, or I want you mainly to focus on the x-intercepts. So let's look at this next one. Here we have x squared minus 9x plus 14. A is 1. B is negative 9. C is 14. Set up our x games. A, C on the top, so 14. B in the bottom, negative 9. A over something, or A over something, 1 over something. Two numbers that add to 4, or two numbers that multiply to 14 and add to negative 9. Negative 7, negative 2. And so this will be equal to 1x minus 7 times 1x minus 2. You don't have to put 1x, you can just put x, but, I like it just in case some students need to see that. We got our factored form already. And so the x-intercepts will be at 7 and 2. See? And let's draw that. 7 and 2, so 2, 0, and 7, 0. And what's in the middle of 2 and 7? They're 5 away, so 2.5 away. You can also add them and divide by 2. 2 plus 7 is 9. 9 divided by 2 is 4.5. So the axis of symmetry will be the line x equals 4.5. Now we typically will need to find the y value for the for the vertex, but I'll just give it away for now. It's going to be negative 6.25. So we'll have the vertex at 4.5 comma negative 6.25. And what we learned, on the page before, is that the y-intercept will be at 14. So we can further draw a point over here at 0, 14. See all these, see how great this is? And we can really start to make a parabola without really even doing any calculations. And maybe let's see if you know what this point would be. 2 more than that, 2 more than this. 9, 14 over here. To see the power of understanding these concepts. I want you to do 2 more. And again, when you're doing this, I advise trying them first on your own. So maybe go ahead and pause the video, try the problem, and then unpause it once you think you got the answer down. But here I go. For C, we're going to have A be negative 1, B be equal to 10, and then C be equal to negative 21. All right, and let's go with good old pen pilot G2. Factoring this, X diamonds or X games, AC on the top. Now, here's the thing. Make your life much easier. Factor out the negative 1 because you don't like x squared being negative. When it's negative, it makes your calculations a lot more complicated. It's still possible, but I'm going to make this into negative 1 times x squared minus 10x plus 21. All that happens is that the negative 1 goes on the outside, and then you're just factoring this. Meaning that my A here will be 1, my B here will be negative 10. Let me write this over. A here will be 1, B will now be negative 10, and C will be 21. This will be the new numbers I'm going to use for those letters. And so AC will be 21, B will be negative 10, A over something, two numbers multiply to 21 and add to negative 10. It'll be negative 7 and negative 3. Now, sometimes again, just by coincidence, you don't have to factor the negative 1 and you'll still get the correct solutions. But just to be certain, I always advise factor out the negative 1 because you don't know when you're going to get the correct or incorrect solutions unless you already know what the solutions are, which has been pointless in the first place. But just be careful of this one thing, and then everything will work out fine. And so then, when you throw this back into your factored form, what you will have is, let me write it over here. F of x will be equal to, keep that negative 1 on the outside, and just use this for this part, negative 1 times this with the factored terms in there. So 1x minus 7 times 1x minus 3. And this will be your factored form. See, all that happens is that negative 1 goes on the outside and life is good. And so the x-intercepts will be then at 7, 0, at 7, 0, and 3, 0. Let me just write them out. 7, 0, and 3, 0. Making our x-axis, y-axis. Three, 0, 7, 0. Y-intercept is at negative 21. So let's just say it's over here. Just again, not drawn to scale. And I'm doing additional, work because this is really fun. I'm really enjoying it. The vertex will be halfway between 3 and 7. So that will be at 5. So this is the line x equals 5. Cool, yeah. And if you calculate where it is, it'll be actually at 5, 4. And this doesn't look like a parabola, but it's still good. But had a bad morning. Just got out of the shower. All right, one more of these guys. Try this one now. Well, because I will get after it right now because we have a is negative 1 here. So I'm going to make f of x equal to negative 1 times x squared plus 5x plus or minus 24. Now I use the a, b, and c from there to make my life much more fun and fulfilled. 1, 5, and negative 24. Using the power of the x games. A, c on top, negative 24 on top. B in the bottom, so 5. 1 over something, a over something. Two numbers that multiply negative 24 and add to 5. Which will be, yeah, negative 8. No, positive 8 and negative 3. Break that up. We will then have f of x be equal to negative 1 times 1x plus 8 times 1x minus 3. 1x plus 8 times 1x minus 3. And there's my factored form. X-intercepts will be a negative 8, 0, and 3, 0. There you go, x-axis, y-axis, negative 8, 0, and 3, 0. Opening downward because a is negative. And the y-intercept will be a 24. Let's just say that's 24. It looks like a 24 to me. 0, 24. And the vertex halfway between negative 8 and 3. They're 11 away. So what's 5.5 away from negative 8? Yeah, that's right. It's going to be negative 2.5. So we'll have the line of symmetry be equal to negative 2.5. It would actually be way up. Let's take this uptown. It'll be at negative 2.5, comma 30.25 when you do the calculations, which I did because I like math and it's fun and it gives me meaning. I'm sorry, I didn't mean to ramble there, but there's your parabola, and it should look much better than this. But you get the picture, hopefully. Remember, it's just sketches just to get your conceptual understanding down. And don't worry about being Picasso. But there you go for the x-intercepts strategy. So go ahead and feel free to take a break, get some water, just do a little bit of a workout, do some push-ups, and I'm gonna get back at it in just a minute. All right, so what I essentially was showing you with those intercepts strategies I use for graphing was basically what they call a zero product property. Basically what it means is find the zeros or find where the y value of the graph is 0, which will be at the x-intercepts, and make the parabola go through that and, figure out what it's going to look like. So the zero product property being formally defined here is essentially looking for factors that make the equation equal to zero, which could, be multiple. We could have multiple x values. That's what this fancy notation means: x0, x1, x2, x3, x4, x5, blah, blah, blah. And we must consider that they all could be zero, or one or more of them could be zero. But usually in quadratics, you're not going to get more than two. But this is applied to higher level polynomials. But don't worry about that for now. Now, make sure you don't mix this word up, because students will, I don't know if they overthink, but when we say zeros of an equation, we're talking about x-intercepts. We're not talking about zero. But they're called zeros because the y value is zero there, but it doesn't mean plug x equals zero into the equation. So here's some steps that I'll typically advise my students to use when applying this. Start off by setting the equation equal to zero, not x equal to zero again, because again, I'm trying to find the zero or zeros or y is zero. And we factor it if you can. If we can't, I'll show you what you do next in the next lesson. But for now, let's only consider the cases where we can factor in some form like this: a times x minus x1 times x minus x2. And then we set each of these factors equal to zero. We'll set x minus x1 equal to zero and x minus x2 equal to zero. That's essentially how we find the x-intercepts, by just looking at the opposites, because that's just how math works, without really even thinking about it. So let's finish this off with, two super fun math problems, because that's what I know you've been waiting for. So here we go. It'll be really good ones to see if you've mastered this stuff, because they're not going to be, they're not going to just be simple, easy answers. So we're going to use the zero product property to find the coordinates of the x-intercepts and draw a sketch of it. And let's also draw other characteristics if it makes sense to find them, like the vertex, y-intercept, that sort of thing. So let's start off again by identifying the A, B, and C. A is 12, B is 5, C is -2. Now, always double check to make sure there's nothing you can factor out of all the numbers, because sometimes that'll make the factoring much harder, because the numbers will be much bigger. And so you can't. And so what we're going to do is set this equal to 0. 0 equals 12x squared plus 5x minus 2. And so we're solving for the x values of this equation. That's what we mean by the zeros, and this is what we use the factoring technique for. So let me put it over here. So a times c on top, so 12 times -2 on top, -24. B in the bottom, or 5 in the bottom. A over something, 12 over something, and 12 over something there. And this is where it really helps to have this strategy, because the a is not equal to 1. From here, find two numbers that multiply -24 and add the 5. So what are they? That's right. They're 8 and -3. But here is where you got to simplify these fractions first. If possible, both of these can be divided by 4. So this will be 3 over 2. And we're going to use this 3 over 2 as our factored form. Here, they both divide into 3, so we'll get 4 over -1. Keep the negative with the number that it started with. Keep the negative with the -3 or on the bottom. Don't move it up. Even though mathematically they're equivalent, factoring they're not. So then we use these 4 numbers as usual, and we set this 0 equal to that. So 0 will then equal 3x plus 2 times 4x minus 1. And from this, we have two factors, or two equations we're going to solve for 0. We're going to have 0 equals 3x plus 2, and 0 equals 4x minus 1. Yeah. Solving this, we get 0, we get negative. We get -2/3 is equal to x. we'll call this x1. This would be our first root, our first zero. Whoops, negative 2/3. And here, add 1 divided by 4. We'll get 1/4 equals x, and we'll call this one x2. So these are our two zeros. And I like to name zeros. So then we just make our parabola going through these values on the x-axis. Got a lot of space down here, a lot of real estate to work with. X and the y-axis over here. Negative 2/3. Don't be thrown off by it being a fraction. It's still a number. Negative 2/3 comma 0. 1/4 comma 0. Y-intercept negative 2. Let's just say it's over here. 0, negative 2. Yep. Whoops. And then what would then be in the middle, or what would be the vertex at? Well, we want to find the middle of those two values. So we're gonna use decimal approximations, make it a little easier to work with. That'll be negative 0.66 about, comma 0. And this will be 0.25, comma 0. Let's find the middle of those two numbers by adding them and divided by 2. Negative 0.66 plus 0.25 divided by 2. We'll get negative 0.205. Let's just make it there. So we have this line then, x equals negative 0.205. And we find the vertex by plugging negative 0.205 into the equation. And let's do it down here. Y will be, kind of hard to see everything. There we go. So put the negative 0.205 into this equation, which is cool math. Left 5 times negative 0.205 minus 2 is equal to 0.205 plus 5 times negative 0.205 minus 2. I believe I screwed up with that. It doesn't make sense. Negative squared 12 times negative point. Hold on a second. I think I did it backwards. Wait, no, I didn't. Did I? Oh man. We'll see what's going on. Negative 2/3, 1/4. Let's try this again. Negative 0.66 plus 0.25 divided by 2. No, I'm good. I'm good. I'm solid. So then negative 2.5207 should be where the vertex will be. Negative approximately. So vertex will be at negative 0.205, comma, negative 2.5207. But feel free to double check and let me know if I messed up in the comments. That'll be your homework for tonight. And there's your parabola. Maybe I shouldn't use the tall way of the paper, but all right, one more of these guys. The 6x squared plus x minus 1. Now let me actually use a different piece of paper to make sure it all fits neatly. Dun, dun, dun. Okay, so A is 6, B is 1, C is negative 1. And so, factoring AC, so negative 6 over b over 1, a over something, a over something. Two numbers that multiply to -6 and add to 1. 3 and -2, right? 3 and -2. Remember to reduce. 6 over 3 reduces 2 over 1. 6 over -2 reduces 2. 3 over -1. And we're going to use those values for that. So what we do is, remember, set this equal to 0. To set f of x equal to 0, so we'll have 0 equals 6x squared plus x minus 1. Use the power of the factoring to solve this 0. 0 equals 2x plus 1 times 3x minus 1. You have your two equations that you want to solve. So 0 equals 2x minus 1, and 0 equals 3x minus 1. Adding 1 divided by 2, we get 1/2, or -1/2 equals x1. And adding 1 divided by 3, 1/3 equals x2. Right? And we just keep on going. We just I have the glare in my eye right now. Okay, there we go. Well, yeah, we have the x-intercepts there. Not much more to do than to make your sketch. Let's make the sketch, yeah. X-axis, y-axis, -1/2, 1/3, then -1/2, comma 0, 1/3, comma 0. Y-intercept is -1, so it's 0, -1. And let's find the middle of those two numbers now. Hopefully it works out more simple than the one before. This is the same as -0.5, comma 0, and this is the same as 0.33, comma 0. And we add those together and divide by 2. So 0.33 minus 0.5 divided by 2. In the middle will be 0.085, or -0.085. The beast, let's just say it's over there somewhere. And so this would be x equals -0.085 for the axis of symmetry. Evaluating this, plugging this into the equation for y, we will get that y will be 6 times -0.085 squared plus a -0.085 minus 1, and we will get -0.085 squared minus 0.085, -1.042-ish. All right, -1.042. Yeah, that makes sense. And let's just put the vertex, let's put it over here. The vertex will be at -0.085, comma -1.042. All right, and then we got a cool, good-looking parabola. Maybe not so good-looking, but it's okay for a sketch by hand. And there you go. Now, I'll let you know if you can graph your parabolas by doing this, you can pretty much, graph it any other method. And all the other stuff in this unit will probably be much easier because this is really conceptual. We don't even have a graph to go by. So this is like why I like showing you guys this early in the unit, because it really develops that mental representation and makes sure that you guys aren't just tediously calculating your way through the unit. But there we go. We'll take a break for now. That's the end of this lesson. So here's my duck. Let me know if you have any questions, or maybe I, did something wrong or rushed really quickly, or maybe didn't explain something clearly. I'm a teacher, so I'm open. I'm used to criticism, but anything that you can help me become better will be greatly appreciated. And if I did something good, let me know that too. And subscribe no matter what, because that'll make you a better person. Give me a like, and then also let me know what else you would like me to cover in my next video. All right, I'll see you guys later.